All right, guys, I apologize. I don't know exactly where my video cut off. I was going to use this formula, though. I changed my mind. I think it's easier, like less formulas, the better. Okay, so now we know the first term is 4, and we know we're doubling each time the common ratio. So that means that A2 is 4 times 2, which is 8. A3 is double that, 16, and A4 would be 32. Boom, right there. Okay, an infinite geometric series. So infinite series, you do need to know this formula. S, you don't need to put the infinity sign there, is 1 over, oh my gosh, I just had it the other day. Let me double check it. I just wrote it down and I forgot it. If you don't use it, you lose it, right? So, sum of an infinite. It's A1, my bad. It's A1 over 1 minus R. Okay, so A1 over 1 minus R, you will need to know that for the test. Okay, so it says it has a A1 of 6 and a sum of 9, find R. So your sum is going to go here, right? S equals 9. We're looking for R and A1 is 6. So 9 equals 6 over 1 minus R. So you can cross multiply if you want. I would go ahead and cross multiply. So I'm going to say 6 equals 9 times 1 minus R. You could distribute through or just divide by 9. It's up to you. I'm going to distribute. So I get 6 equals 9 minus 9R. Subtract the 9 over. I get negative 3 equals negative 9R. Divide by negative 9. R equals 1 over 3. So 1/3. Okay, next one, which is a cubic polynomial in standard form with roots, meaning x equals 0, x equals 2, and x equals -1. Those are my 3 roots. So my factors are move everything over. X minus 0 doesn't do anything, right? And then minus the 2 over, x minus 2, add the 1 over, x plus 1. Now multiply these guys out. When I multiply these two, I get x squared minus 2x plus 1x is minus x, and then minus 2. Don't forget you have an x out front. That's x cubed minus x squared minus 2x, which would be C. All right, moving along, use long division to find the quotient. So I'm going to rewrite it as negative 2x plus 3 divided into 4x to the 4th plus 12x cubed. Be careful, make sure that each degree is there, and it is, so you're fine. But if it's not, you need to put a 0 in as a placeholder. Okay, so I'm looking for something that when I multiply it, I get 4. Negative 2 times negative 2 is 4. So negative 2, and then x times x to the 3rd is x to the 4th, so x to the 3rd. Multiply back to both of these. Don't forget. So that's 4x to the 4th, and then minus 2 times 3 is 6, 6x cubed. Switch, switch. That's 18x cubed. And then we're going to continue on. I'll try to change up the color each time. So negative 2 times negative 9 will give me positive 18. And then x squared times x is x to the 3rd. So that would be x squared. Oh, and don't forget, I almost forgot, right? Bring down the next term, plus 7x squared. Now I'm going to multiply negative 9 to all of that. Negative 9, that's 18x cubed. And then that'd be negative 27x squared. Switch, switch. That's 34x squared. And bring down your next term. And then negative 2 times negative 17 is 34. And x times, oh, that should be an x squared, my bad. X times x is x squared. So negative 17 times that is 34x squared. Negative 17 times 3, I think that's 54 or 51. Let me check it. 3 times 17 is 51. And that'd be negative 51 x, switch, switch. And that becomes 52x. Bring down my last term, which is 6. negative 2 times, oh gosh, 52 divided by 2. 26. Negative 26, multiply back. That's positive 52x, and then negative 26 times 3, 78. Whoops, minus 78. Switch. And that becomes 84. So plus 6. Just checking. Yeah, 84. And this is my remainder. So I'm going to put my remainder, positive 84, over my divisor, negative 2x plus 3. Be careful when you enter it, right? You have to enter it in exactly this way. All right, and then if your remainder would have been 0, then this would have been a factor. It says, so is this a factor? No, because the remainder was not 0. Okay, find the roots of. So to do that, we're going to use the rational roots theorem, which is all the values of p to q. And I'm going to use synthetic division. So my q to my p, right, is going to be plus minus 1, plus minus 2, plus minus 5, and plus minus 10 over plus minus 1, right? So, oh, I wrote this backwards. P and Q, right? So all of these values over this are just these values, right? So I'm going to try each of these. Now I notice that all of these could work. So I don't get any like freebies yet. So I have to try one of these. You just have to guess and check, and I'm going to try 1. I might be wrong, but I'm going to try positive 1. And I'm going to do synthetic division. Remember, you just write your coefficients. So that'd be 1, 3, negative 5, negative 9, and 10. You bring the first one straight down. Multiply, add downward. Multiply, add downward. Multiply, add downward. Multiply, add downward. Awesome, I found it the first time. 1 is a root. Now, you notice I divided this by an x, and so these are going to be 1 degree lower. Or this is my remainder, my constant, my linear, my squared or quadratic term, and this is my cubic. So this is 1x cubed plus 4x squared minus 1x, and then minus 10 with no remainder. So you notice that I have the same 4 values here, right? All the ways to multiply to negative 10. 1, 2, 5, and 10. That's kind of nice, right? So I can just try it again. I know 1 was already one of them, so I'll try, or 1 is excluded from here. So I only have 2, negative 2, 10, or negative 10. I'm going to try positive 2. And again, 1, 4, negative 1, and negative 10. Multiply, add downward. Multiply, add downward. I'm not feeling good about it, right? Multiply, it is not 2. Now I'll try negative 2. Multiply, add downward. Multiply, add downward. Multiply, add downward. It was negative 2. Okay, so now, again, this is my remainder, my constant, my linear, my quadratic. Now I have a quadratic. This is my x squared plus 2x minus 5. And now I could use the rational roots theorem again, but it'd be easier just to use the quadratic formula. This does not factor. You can tell because my answers are decimals. So I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, which is 20, plus 20, over 2a. And then use your calculator, so you get negative 2 plus or minus the square root of 24 over 2. So I'm going to do negative 2 plus the square root of 24, and then divide it by 2. One of my answers is 1.4, right here. And then negative 2 minus the square root of 24 divided by 2, which is negative 3.4. Boom. All right, again, I just used my calculator to simplify that. So my 4 answers are right there. Okay, so the number of inflection points, right, or the number of times that this changes direction tells you the degree. So it starts off downward, switches to upward. So that's 1 switch, 2 switch, 3 switch. So you've got 1, 2, 3, 4 directions, right? Down, up, down, up. So it's a degree 4. Or you could look at your inflection points. 1, 2, 3 inflection points tells you it's 1 more degree. So this is a degree 4. If it's an even degree, which it is, we have 2 cases, right? Either A is positive, which means it's up, up end behavior, or A is negative, which means it's down, down end behavior. Well, our end behaviors are up, up, so A must have been positive. Now, if we had an odd degree, if A is positive, it will start off negative and go upward. If A is negative, it will do the opposite and do something like that. So you need to know those 4 cases. So in this case, the degree was even. So it has a degree of 4 or even. And the leading coefficient was positive. A is greater than 0 or positive. Now, how many real roots does it have? The real roots are where it crosses the x-axis. So it has 2 real roots. I don't know if you can see that. 2 real roots. And it has to have 4 roots total. So if it has 2 that are real, the other 2 must be imaginary. So these have to add to the degree, which is 4. So you can see it says even, positive, 2, and 2. All right, moving along. Question number 26. Oh, I think this is the last one. It says, determine which of the following binomials are factors. So we're going to use that rational roots theorem again. So we need something that the leading coefficient is 1, so all of these are over 1. So plus minus 1, plus minus 2, plus minus 3, and plus minus 6. All the ways to multiply to that coefficient or that constant term of 6. So you notice they all show up except for 6. So I'm going to get rid of 6 because 6 isn't there. I'm going to try 1. If I try 1 with synthetic division, let's see what happens. If I get a remainder of 0, then it's a factor. So it's 1, -1, multiply -1, -6, 1, -6, 0. Awesome. So 1 is a solution. X equals 1 is a solution. That tells me that x minus 1 is a factor. So x minus 1. Okay, now I can't just get rid of x plus 1 because plus 1 could be a solution as well. I'm sorry, -1 could be a root as well. So you see how this would have been, your solution would have been 1, right? Okay, let's try another one. I'll try 2. So 2, using the same, oh, actually, now that I have reduced this, I'll use this quadratic, and this is my constant, my linear, and my quadratic. So this is x squared, right, minus x minus 6 equals 0. Now I can see this factor is really easy. So what will multiply to -6 and add to -1, which is -3 and +2. That means that these are my other 2 factors. So x minus 1, x minus 3, and x plus 2. Boom. There they were. All right, guys, that's the entire review. I hope that you study and you use the opportunity to bring your grade up. And I miss you all. Sorry that we had to end the year this way. I wish it was different, particularly for my seniors. But, you know, better staying safe and healthy than, you know, risking a worse thing happening. So, all right, have a great day, guys.